Welcome back to Connect and Transform. In today's video, we're going to go over a logic puzzle called Foggy Birthday James. I didn't write it, I found it. The rules state normal Sudoku rules apply. Dynamic fog, most of the grid is covered in fog, so you don't know what it is or what its configuration is. Placing a correct digit may do nothing, or it may clear some fog somewhere in the grid, possibly revealing other clues. No guessing is necessary. That's probably the most important piece of information. So we can solve this entirely in logic. Killer cages, digits do not repeat within the cage, and sum to the total in the top left corner of the cage. I found that with fog Sudokus, knowing that the number is in the top left is sometimes a clue in and of itself, because sometimes you can't see the total shape of the cage, and you know then that the cage does not extend further to the top and left if you can see the number. Kropki dots. Digits separated by a white dot are consecutive. Separated by a black dot have a ratio 1 to 2. One is double the other. So we see here that we can see the entire cage. We can see the border completely, so we know this is exactly two cells that add to 11. We also see there's a white dot in the middle, so there must be two consecutives that add to 11, so it must be 5, 6. We see there's a black dot connecting these two, so there's a 2 to 1 ratio. And because normal Sudoku rules apply, we know this one can never be a 5 because this can't be 2.5 or 10. So we know that this is exactly a 6 and a 5, and because of the 2 to 1 ratio and normal Sudoku rules applying, that must be a 3. So now we've got another 2-cell 11 with a 3 in it, so that's an 8. Now we've got another 2-cell 11 in the same row, so it can't be 3, 8, or 5, 6. It could only be 4, 7, or 2, 9. Now we've got a 26 cell in the same box. Again, digits can't repeat in a cage or in a box. Let's maximize 3 digits, 7, 8, 9. That would make 24 and leave us with 2. So it could be 2, 7, 8, 9. And then what variance could there theoretically be? Well, theoretically, you could push the 2 and 7 closer to each other. So it could also contain, and I know the top row is not going to allow most of these, but it could also be 3, 6 instead of 2, 7, or it could be 4, 5, and that's it. So yeah, let me get these out of there. Okay, so for example, you might have like a 4, 5, 9, 8, or something to that effect. Let's look at the row. We're missing a 1. Okay. So now we have a 4-cell 26 that's also in the same cage, same box. So that one could be a 2, 7, 8, 9. Now we know in this case that we can't push the 2 and 7 closer together. It can't be 3, 6, 8, 9 because 3 and 6 are already in this box here. It also can't be 4, 5, 8, 9 because there's already a 5 in the box. So it has to be precisely 2, 7, 8, 9 in this case. There's also a white dot noting consecutives here, and I'm thinking this can't be 7, 8, 9 because the 6 is already taken in this box. So this cell here can't be a 6, and if all the 7, 8, 9s are used in these 4, then you can't have a 7, 8, 9 here. So this has to be a 2. And then because the 3 is already taken in the box, and it's consecutive to 2, that has to be a 1, that has to be a 4, and we've uncovered some additional clues. Just going to do some cleanup real quick. We have yet again a 4-cell 26, which could be a 2, 7, 8, 9. Actually, it could be a lot of things. So I'm just going to note the 8, 9 for now. Um, okay, so here's something. If this is a 4, 7, then these two have to be 2 and 9. And if these two are 2 and 9, then these two have to be 7 and 8. There's no other possibility. The problem with that is that if the two on the right are 7 and 8, then the two on the left are 9 and impossible. So this can never be 4, 7. And then because we know these two are 2 9s, 2 and 9, these two cannot be 2 and 9. So now we know there is a 4 and a 7 in this particular 26. And what does that leave us with? So that's 11. That leaves us with 15. Is that right? I think that leaves us with 15. So the only way to get to 15 without doubling up a 4 or a 7 is to do 6 and 9. Let me just think about that. Yeah, no, that's correct. So this has to be 6 and 9. So we know there's no 9 here because we've already used the 9 over here in this row. And so here we know these two are 7, 8. So now we know this one is exactly a 9. I'm surprised that nothing was revealed. Okay. Oh, well, here we've got. Oh, well. Oh, no, this isn't a real marking. I need to be very careful here. All right, let's refocus our attention. Okay, so like there's a 2 here in the row. So this can't be 2. We know there's no 2 in here. That's not a 2. So this is the 2. Okay. We know there's a 7 in the bottom there because there's a 7 and a 7. So this is the only place in this row that could be a 7. Likewise, we know this has to be from 3, 5, and 8. And then the other two digits here are 4, 4 and 6. And then here would be 1, 3, 5. So there must be something in these. Let's add these together. So this is 26 and this is 11. So that's 37. And we know that the digits 1 through 9 add to 45. So these 3 digits here have to add to 8. So that could be 125. It can't be 125 because 1 and 2, that would only leave one possibility. So we know that it's not 125. So the only thing that it could be is 134. And because of this 1, we know these two can't be 1. So this is exactly 3 and 4, and this is exactly a 1. Okay, so now we have a 2 to 1 ratio. That can only be a 2. And then because all of these are in the same row, this 2 to 1 ratio can't go back down to 1. That has to be a 4. Then there's a consecutive to 4, which is either 3 or 5. And we see from our markings that this must be the orientation 9, 2. Let's clean up that 4 there. All right, so we've got another 2 to 1 ratio here. It can't be 3, 6 in any orientation because that 6 sees that column. It also can't be 1, 2, or 2, 4 because of this 2. So the only possibility here is 4, 8, and we have a 4 here that sees the bottom one. So we know the bottom one can actually only be an 8, and that must be a 4. And so now we know the orientation of the 3, 4 there, and we've uncovered some additional information. Let's clean up that marking. We know this is a 7 and an 8. Okay, so now we have a 4 square 11. Now I know that for four digits, 1, 2, 3, and 4 add to 10, so it needs to be 1 off of that. And the only digit that we can push out is pushing the 4 to the 5, because if we push any other digits, it'll collide and we'll have a duplicated digit. So this must be precisely the digits 1, 2, 3, and 5, and these two can't be 2. Okay, so now we have 1, 2, 3, 5 quadruple there, which leaves us with what in that column? It leaves us with 4, 6, 7, and 9. Now there's a 4 there. So this, other than, actually, yeah, this square is fully pencil marked. So this column is fully pencil marked. This is fully pencil marked. The only ones that are not fully pencil marked are those 4. Let's look here at the bottom row, because we've got this 11. It can't be 2, 9, because there's a 2 there. It can't be 4, 7, and it can't be 3, 8, because there's a 4 and an 8 seeing it. So the only thing it could possibly be is a 5, 6. And so now we've got 1, 3, 4, 5, 6 used up here, and so we actually do know these digits now. We know that they can only be 2, 7, 8, 9 in some order. Okay, now we've got a 5, 6 here, so the 5 is consumed in the row, so this must be a 3. And what does that leave us with? 7 and 9. So this one must be a 7, because there's a 9 up here that sees it, and so this one must be the 9. Let's clean up some of our markings. Okay, let's look maybe at this column here. So this is missing 1, 3, 5, and 9. I mean, we know that these 4 digits are taken here, so we know that of these 5, it must be from 4, 6, 7, 9, and 8. And I know that there's a 9 here that's going to see these, but I'm just going to mark that in. 4, 6, 7, 8, 9. Okay. All right, so we've got a 3 that sees that, and we've got a 3 that sees that, and we've got a 3 up here that sees that one. So we know that the 3 must be in one of those 2 positions in this box. What about 2s? So we've got a 2 that sees this. We've got a 2 that sees that. I guess that doesn't help. Yeah, that's not helping. Okay, so we do have a 4, 6, 7, 8 quadruple here. And so the remaining 3 would be from 1, 3, 5, but there's a 3 here, so the only place a 3 can go is there. And this must be a 1, 5 pair. And so then these 4 are from 6, 7, 8, and 9, but these 2 can't be 8. Okay, so we've got 1, 3, 5, 1, 5. Let me switch back over to this column. This is probably where I'm supposed to be looking. Maybe not. Let's look down in this box here. Okay, let's look at this column. I don't know what just happened. All right, yeah, let's look at this column. Where can 8 go? 8 can only go in this box. And actually, I'm noticing that this can never be 8 because this is in an 11 cage. So I'm just going to take the 8 out of there. But also 8 can't go there because we knew that 8 was restricted to this column within this box. Can this ever be a 7? No, because as I look here, the only possibilities that actually add to 11 are 7 and 4. So now we know this has to be a 6. This has to be a 7, a 4. Okay, so now we have an 8, 9 pair here, so this can't be 9. Now we've got a 6, 7 pair here, so this can't be 6. That has to be a 9. So now we have a 1, 3, 5, 9 quadruple. We know that the 9 has to be there in this box. I guess we already knew that because there's a 9 there and a 9 there. Oh, we've uncovered this 4 cell 11, and we know from this 4 cell 11, so because this is in a, well, because digits can't repeat and also because it happens to be in a box, these must be exactly the digits 1, 2, 3, 5. And we can't have a 1 there because of this 1, so this is the 1. All right, now we've uncovered that. It's consecutive with 6, so that's a 5, 1. So now we've uncovered a 26 5-cell cage. Okay, so this is a 2, 3, 5 triple, so this can't contain 2, 3, or 5. This can't contain 2, 3, or 5, so that has to be an 8. This now has to be a 5, a 3, 6, 5. So now we've got a 7-9 pair, so this can't be 7 or 9. Again, we got a 7-9 pair in the column, so this has to be 6, this has to be 4, and 7 and 9 go over there. Let's look at this column now. We've already accounted for 2 and 8 here, so we're missing 4 and 6. That's 7, 8, 9. There's a 9 and a 7 there, saying that that's an 8. So that's a 7, 9 pair. This has to be from 2, 3, and 5 because we've got 2, 3, 5. Nope, that's not necessarily true. My eyes skipped over this one. So in this row, we're missing 2, 3, 5, and 6. Now, obviously, there's a 5 looking at that, so this can be from 2, 3, and 6. There's a 3 looking at that one, so that can be from 2, 5, and 6. Okay, this is almost a 1, 2, 3, 5, 6, 9, but not quite. So let's think about the other digits. 1, 2, 3, 5, 6, 9. So that would leave us with 4, 7, and 8. So where do 4, 7, and 8 go in this box? Well, 7 and 8 already exist in this column and in this column. So actually we know that both the 7 and 8 must be in this column. And because 7 and 8 already exist in this row, we actually know that this is exactly the 7 and the 8 in some order. Now what about 4? Well, we've got a 4 here in that column, we've got a 4 in that column, and we've got a 4 here. So we know that the 4 must exist in one of those two. Okay, well, let's look at this last box here. What are we still missing? We're still missing a 1 and a 2. We already know the 3 is in one of those two positions. So in theory, I think any of these can be a 2. And I think, well, these can't be a 1. This is already marked as a 1. I highly doubt that this can be a 1 given that this is a 5-cell 26 gauge, but we'll leave it in there for now. We still got to go through 5 and 6 here. So these two can't be 5 because a 5 sees it. This one's already marked as 5. So that could be a 5. Could be 6. This can't be a 6 because of that one. And these could be 6s. Okay, so I think now, as long as I mark that one with a 3, I think this is completely marked now. So we almost got like a 2, 6, 7, 8, 9 quintuple there. Oh, there's a consecutive clue here. So for example, this one can never be a 9 because 8 isn't a possibility over here. So the only possibility is 7 and 8. And now we're just filling in the ones that are the only possible answer remaining. Okay, so let's go clean up some of our markings. And this one can't be a 6. Okay. So now we've got these two add to 15 and these 5 add to 26. So that means that these 3 have to add to 11. I suppose to start with, I should finish marking out this box. I don't think I ever marked this column. So what are we missing out of these 5 cells? We're missing 1, 2, 4, 5, and 6. Now we already know this one here can't be a 1 or a 4, so this is already fully marked. So 1, 2, 4, 5, 6. And I think at this point, because everything's fully marked, I don't need the corner marks anymore. So these 3 need to add to 11. So I'm noticing, for example, you can't repeat digits in a cage. So we can't do, like, looking at these 2 cells, you can't do 6, 6, 6, 5, 5, 6, or 5, 5. We also can't do 1, 2 because this one can't be an 8, and they have to add to 11. So that means there must be exactly one of either this 2 or this 1 that exist in the answer. So if this is a 1, and now this is where I'll use corner markings again, then these 2 would have to add to 10. And the only way to do that without duplicating a digit, in other words, the only way to do that while respecting the rules of Sudoku, is for that to be a 6 and for that to be a 4. Okay, so the other possibility is that this one is a 2, which means that these 2 would now have to add to 9. And the only way to do that would be for that one to be a 5 and for that one to also be a 4. So in every possible scenario, this one must be a 4. And we've uncovered more fog, so we know that we're still on the right track. And now we're just going to fill in digits that are down to only one possibility. And then we'll clean up our markings, continue filling out cells with only a single possibility. And I'm noticing now that all the remaining fog has already been completed. So the fog isn't really part of the game anymore. Okay, so this was a 4. That's what we did most recently. So now these 2 have to add to 7. So yeah, this can only be 2 or 6. It can never be a 5. And this can only be 1 or 5. It can never be a 6. I don't think we need the corner markings anymore. So now, let's see if there's anything we can do along the rows that are affected by these 3. Well, like right here, we've got a 1, 5 pair, so this can't be 1 or 5. That actually leaves us with only one possibility. And we fill in everything that has only one remaining possibility. Okay. Oh, and now we have this 5-cell 26 clue. So we remember that these 3 had to add to 11 because these 2 added to 15. And these 2 add to 10, so we know this has to be a 1. And then we just fill out the remaining digits. Solved. Thank you for watching.